Okay, here we are, back to skill drill 7.6. This time we're going to go over questions 4 through 6. Questions 1 through 3, the solutions are given both YouTube video form and print form, both links on the daily workout. Let's go on question 4. So here we have a pitcher sliding at the home plate. So here's the ground. You can make the pitcher like a block. You don't have to get fancy in this course. Givens with units. What'd they say? His weight, 1.1 times 10 to the third. That's 1,100 newtons. Coefficient of friction, he's sliding, so it's kinetic, 0.64. And he slides to rest, so VF 0. Not you're necessarily going to need that. And the distance is 2 meters. All right. So this direction is your D, 2 meters. All right. So let's get some forces on here. Of course, this pitcher's got an FG, which we said was 1,100 newtons. Flat ground, no diagonal poles. We also have here an FN, which will match the FG, 1,100 newtons. And now, are there any other forces involved? Well, yes. He's sliding to rest, so something's changing his velocity. That's an acceleration. There must be a force on here acting. There must be a net force acting. In this case, of course, the force that's acting is the force to slow him down, the force of friction from the ground. Here it is, FF. Now, you got to find your FF. FF is your coefficient FN. Fortunately, we have all of those givens. And the FF comes out to, let's see here, 0.64 times 11. Oh, we should know this. 0.64 times 1,000 would be 640, another 164, so it should be 704. Yep. 704 newtons. Good. Now, any other forces acting? Well, there's no pull, so no F external, and that actually is all of it. So here, your net force in this diagram is actually the force of friction, so it too is 704 newtons. All right, time to do the works. All right, work, WG, FGD, but it's important to recognize FG is down, displacement is forward. That cosine here is going to be 90 degrees. In other words, does this downward force cause a forward displacement? No. 0 joules. Same thing is true with the normal force. 0 joules. Frictional force, however, does do work. Work done by friction. FFD. If you want to be technical about it, put that cosine of 180 degrees in there. You got 704 newtons times 2 meters. Cos 180. So that's about 1,400 or 1,408, maybe you call it 1,410 joules. And if you're careful with the cosine, technically that's negative. The net work, which is the sum of the individual works, and is also F net times D, comes out to that same negative 1,410 joules. If you left off the negative, you're okay. In this course, we don't get you for that. All right, good. There it is. Done. Let's go on to the next question. Next question is number 5. There we go. So let's see what's doing in number 5. 20 Newton block falls freely. Okay. Falls freely from rest at a point 5 meters above the surface of the earth. So here's the earth. Here's the block. A few things we know about it, Givens with units. Falls freely means the acceleration is little g, 9.81 meters per second squared. They also told us the block's weight is 20 newtons. And from 5 meters, from a point 5 meters above the surface of the earth. All right, let's get over here. I left a little something out over here, but we'll get that in a second. So the displacement is down. What I left out here is to the ground. So this problem should be to the ground. So then displacement will be 5 meters downward here. Let's put our forces in. We got Fg. They already told us it's 20 newtons. Do not go multiplying it again. They give you a mass, you'd have to adjust it. But here is a weight already, so you're good to go. Fg 20 newtons. Alright, good. Let's keep going from here. What other forces exist? Well, it's falling freely, which means no friction. So that falling freely means the friction is 0. There's no rope or outside pull. There's no spring. There's no touching the ground for the normal. That's it. That's the whole thing. So we got our F net over here. F net is just the Fg, which is at 20 newtons, also downward. And, oh yeah, by the way, back on question 4, good habit, put the direction of the F net near it. F net in this case was to the left. Alright, let's go back over here. So, what do we got? Let's do the works. Work gravity is going to be FGD. The two of these are aligned. So, good to go. 20 newtons times 5 meters, 100 joules. The net work is, of course, the sum of the individual works, or F net D, which in this case will also be 100 joules. Boom, done. Alright, 1 to go. So, yesterday's skill drill was primarily equilibrium scenarios. This one is not. And these are running through pretty quickly. Alright, number 6. 10 kilogram cart is accelerated by a pull along frictionless ground. Here's the ground. Here's the cart. Let's put some info on here. Givens with units. We got a 10 kilogram cart. We got an acceleration. We got a pull. So there's some pull in here. In fact, why not draw it in? F external. And we have a distance. 10 meters. No friction. Alright. So, displacement here. 10 meters. Alright, what we got going on here? Well, we know there is an FG. FG. Now we can approximate this at 100 newtons. Really it comes out to 98 newtons, and in case you don't remember how, Fg is mg, so it's the mass, that 10 kilograms in the beginning times 9.81. Alright, there's a normal force here. And normal is going to match the Fg. 100 newtons, or 98 if you're going to be more careful with these sig figs. Finally, there's no friction, so no backward pull. In fact, that's the whole picture. We got a net force here. The net force is just the F external. And we might actually be able to figure it out. Yes, because they gave us mass and acceleration. So remember, whenever you know acceleration, bang, jump right over to F net. So F net is 10 kilograms times 2.5 meters per second squared. 25 newtons to the right. It's with this F external. The truth is I didn't tell you right or left, and it really doesn't matter for this problem. Just want you to be able to identify all the forces in the works. So let's do the work. Alright, F external. We know here 25 newtons. We can do gravity, of course you should know right away, 0 joules. Fg and displacement are perpendicular, that's the cosine 90. Now, Siri wasn't sure, but that's alright. Siri, Alexa, whichever one. Normal, also, perpendicular displacement, you know should come out to OJ, 0 joules. The external, however, is not. Work external is going to be F external D, 25 newtons times 10 meters, comes out 250 joules. You, of course, can do the same thing with the net work. And this, of course, will come out to the same, F times D, 250 joules, as it should be the sum of all the works in the diagram anyway. Alright, that's it. Pretty easy one. Fantastic.